everybody, this is Rudra Pradhan here and welcome you all to BMDA course, and we are here today for unit 4 lecture, and that too the discussion is on inferential analytics. In fact, in this series we have 10 lectures, and this is the second lecture of this particular series, and that to address the problem. So, in the first case we have populations, and then we have to draw samples, and through some sample statistics we have to compare and conclude the population statistics. So, that means, it is the kind of the kind of confidence we have to create on the basis of sample and populations. So, the usual procedure is that, so your sample statistics should converge to population statistics, and we are here to see the kind of structures, how to justify this. That means, whether the sample statistic will be converging population statistics, or there is a kind of difference. So, if it is converging, so that means we have to actually justifying the particular fact, and if there is no kind of convergence, that means the sample statistic is not converging towards population statistics, then there is a difference, and that difference we have to highlight what is the kind of the kind of inference, and for that what should be the managerial kind of implications. So, now we have actually discussed in details about the particular structure, and in this lectures we will again repeat the typical structures like testing of hypothesis, steps in hypothesis testing, type 1 error, type 2 error, and some of the basics behind the testing procedures and certain examples, and any kind of investigation process. So, the idea is just to verify the kind of facts, and hypothesis in the kind of in the simple structures we can say that it is a statement which is not verified, and we are here to verify the particular structures. It can be represented in 3 different ways. So, the first structures we can say it is a kind of research hypothesis, and the structure is that it is a statement of what the researcher believes will be the outcome of an experiment or a study. So, it is basically it is a proposed statement, and a researcher or the kind of analyst, so has to think and design accordingly. So, this is as usual actual kind of thought process. Then statistical hypothesis will be a formal structure, and that is basically derived from the research hypothesis, and the third one is called as substantive hypothesis. It is the kind of structure between statistical hypothesis and research hypothesis. That means, we like to just justify that what is the actual kind of belief, and what is the correct kind of scenario with respect to the sampling. So, that means, we are observing certain things, and then with the basis of samples and sample statistics or the kind of experimental process, we have to see, so whether the sample statistic will be exactly following the kind of expectation as per the as usual expectation, whether there is a fact or something different. So, we are here to check all these difference. Then okay. So, in the meantime, I will give you certain examples. What is the structure of research hypothesis? So, research hypothesis means some of the examples like older workers are more loyal to a company, and companies with more than 1 billion of assets spends lot on advertising compared to companies with having less than 1 billion of assets. So, similarly, the price of scrap metal is a good indicator of the industrial production index. So, this is just kind of like observations. So, the observation need to be verified, and then we like to know the kind of statistics or the the empirical process through which we have to justify the structures. So, whether the observations are correctly specified or there is a need of some kind of modifications. So, the inference which you have to draw from this process will be helpful for taking the decisions about this problem. And in the process of investigations, so we like to use actually two hypotheses. So, the first one is called as null hypothesis, then the counterpart is called as alternative hypothesis. So, in the case of null hypothesis, so the idea is that means the representation is it is nothing new, or in the case of alternative hypothesis there is something new. So, that means no no new things are happenings, or something new is there. So, we like to just check the difference whether it is the fact or not the fact. So, that means, so the game between null hypothesis, alternative hypothesis to justify the fact. So, we start with something kind of positive, then we will see what is whether this positive still happening or there is some kind of other way around. And usually in the research kind of investigations, so we denote null hypothesis will be H 0 and the counterpart alternative hypothesis will be H A. So, that is called as a H A alternative hypothesis and H 0 is the null hypothesis. So, in any kind of investigation process, so the first step is to set the null hypothesis and alternative hypothesis, then the investigation starts on the basis of null and alternatives. So, we have to see the particular sampling structure, the kind of test statistic and the kind of procedure through which you have to test the things, and then we will conclude or we will get some kind of inference. So, it is basically the comment behind the observations, and the typical structure is like this. Null hypothesis and alternative hypothesis are usually mutually exclusive. So, that means only one of them can be true at a particular point of time, and in the case of against in the case of null and alternatives. So, they are collectively exhaustive. So, that means they are stated to include all possibilities. So, the another feature is null hypothesis is assumed to be true. However, the proof actually falls on the structure of alternative hypothesis. So, before we start the process, so you should have a clarity between the null hypothesis and alternative hypothesis. So, technically or practically one can be true at a particular point of times. So, we like to check which one is the true. So, whether it is the null hypothesis true or alternative hypothesis true. So, now in the process of investigation null and alternative hypothesis, we will have two different concepts altogether again. So, particular structure is called as one tail test and the counterpart is called as a two tail test. So, then the standard examples we can fix like this. Let us say H 0 is mu equal to 40 and the counterpart mu not equal to 40. So, that means, when we are putting mu equal to 40 and mu not equal to 40, this specifically or this specifies that it is a two tail structures, but if it is not two tail structures, then it will be one tail test. So, it will be either in the left hand side of the game or right hand side of the game. So, what is exactly the left hand side of the game and right hand side of the game? So, I will let you know through the structure called as normal distributions. So, now here all these three structures we can describe. So, in the first case this is one kind of one tail test and this is another one tail test. So, that means, if it is not two tail, so either we are targeting in the left hand side or we are targeting in the right hand side. So, if there is no such specification, then we will be targeting both these sides. In that case, the particular structure will be two tail test. So, that means, the difference between these two for setting null and alternative hypothesis like this. So, the comment on null hypothesis. So, that is actually when we are putting greater than equal to. So, this is a one particular specification, then by default the counterpart will be less than 40, and when we are specifying H 0 p less than equal to some sample structure, then obviously the counterpart will be p greater than, and if not, then we can state that mu equal to something, then the counterpart mu not equal to something. So, that means, in this case we are putting mu equal to 12, then by default the counterpart will be, that is the alternative hypothesis will be mu not equal to 12. So, now corresponding to this, so what will you do? So, I will show you through a particular structures, but before we go to that particular structure about the, that means the normal distribution structure. So, I will let you know the steps, and on the basis of this test I will tell you the particular structure through which you have to comment on the null hypothesis and alternative hypothesis. That means, it is a typically a decision making process. So, the decision making process is like this, we start with a kind of problems, and then we have to justify observations, and that observation need to be tested empirically. So, that means, whatever observation we are expecting or predicting, whether it is correctly specified or some there is a kind of difference. So, we need actually some kind of analytics through which you have to take a decisions. So, the procedure of taking decisions, and that too with the help of inferential analytics, and that too with the help of hypothesis testing is like this. So, there are altogether 8 steps we have to follow to get the inference and then comment on the null hypothesis and alternative hypothesis. So, the first step is establishment of H 0 and H A. So, that is the, that means that is the specification of null hypothesis and alternative hypothesis. So, first you define problems, and then exactly what is the specification of objective, and on the basis of objective we have to formulate the null hypothesis, and then by default its counterpart will be fixed, and that is what it is called as alternative hypothesis. And then in the second step we have to apply the appropriate, or you have to choose a particular test statistics. As we have already discussed, there are 4 test statistics we are supposed to apply when some kind of verification is required. So, that is with respect to Z test, T test, chi-square test, and F test. And again, so we have to connect with sampling and sampling distribution. Then in the third step we have to specify the concept called as type 1 error, that is the structure of or value of the alpha, that is the probability level of significance through which you have to take a decision on the acceptance of null hypothesis or acceptance of alternative hypothesis. Then then we, in the first step we have to take the or we have to call call for decision, and then in the fifth step, so gather the sample data, and on the basis of sample data in the step 6 we have to calculate the test statistics. Then finally, in the 7th steps, so we have to go for some kind of statistical conclusions on the basis of test statistics and the kind of observation here which we have actually stated in the form of null and alternative hypothesis. So, then in the meantime, in the last steps we have to take managerial decision on the basis of statistical conclusion which we have drawn from the samples and through the sample statistics. So, now means test statistics. So, now in the process of this investigations, so the usual testing structure is like this, and we have actually specified 8 steps, and the 8 steps can be actually graphically located like this. So, the first structure is the setting of the null and alternative hypothesis, and then your structure or inferential analytics role is to check or to take the decision whether to accept the null hypothesis or to accept the alternative hypothesis. That is the statement or the observations which you like to target. So, that means, in the kind of business problems we are detecting a kind of problem, and whether that problem is actually a fact or not fact, we have to test empirically, and the process through which you will test, that is nothing called as inferential analytics. And here in the process of these investigations, so we have actually the kind of fixation of alpha, that is the type 1 error. So, the red part is nothing but alpha structures, that is type 1 error fixations. So, what is actually type 1 error and type 2 errors. So, in the next slide I will highlight, but as per the particular steps which I mentioned in the previous slides. So, we have actually prepared a structure here, and in the structure. So, this is the alpha fixations, and it in this case it is both the sides, that is what the two tail structure, and the particular structure is called as critical value, and this side also critical value. So, the the critical value structure is actually obtained, or it can be actually highlighted here on the basis of your alpha specification corresponding to a test statistics and the sample size, that is nothing but called as degree of freedom. So, that means technically to get the critical value you must specify the alpha component, you must specify the test statistics, and then you have to get the degree of freedom. So, that is the adjustment between the variables involvement and the sample size. So, once you specify all these things, then you are in a position to find out critical value. So, now once you specify the critical value, then the critical value left side so will be called as a rejected zone, and similarly critical value in the right side above the right side of this particular zone is called as rejected zones. Then in between critical value this side in the right portion and this critical value in the left portion is called as accepted zones. So, now the idea behind this particular testing or inferential analytics is to see where is the position of test statistics, whether it is coming under the accepted zones or whether it is coming under the rejected zones. So, that means on the basis of samples. So, you have to find out the samples statistics, and then you have to see the locations with respect to this particular testing kind of structure. So, if your testing structure is like this, so that means your test statistic is coming in the red sides, both the sides, then it is actually rejected zone. So, that means the rejected zone means it is the question of rejecting the true null hypothesis, and if you are not rejecting the true null hypothesis, then it will be in the accepted zone. So, in that case we have to accept the you are not in a position to reject the null hypothesis. So, you have to finally accept the alternative hypothesis. That means, what we have already highlighted in the previous slides, that at a particular point of time one must be true. So, both cannot be go simultaneously. If you are rejecting the true null hypothesis, then you will conclude as per the particular structures. If not, then you have to accept the alternative hypothesis, then you have to just take the decision in the opposite directions. So, accordingly the test structures will be like this. So, then I will take you to the kind of structure here, the concept called as type 1 error and type 2 error. So, the concept of type 1 error and type 2 error is nothing but rejecting the true null hypothesis or accepting the false null hypothesis. That means, when you have actually setting the null hypothesis, so it is the true or it is the kind of false. That means, it is a statement which you are putting. So, the statement which you are putting by default will be represented as a called as null hypothesis. So, the statement may be true, may be false. So, that is why we will give two options. So, that is how the decision making will be taken care. So, null hypothesis true and false, and then you have two options to reject and accept. So, that means, it is nothing but actually the square matrix of 2 into 2. So, null hypothesis true false, and then null hypothesis acceptance and to be accepted and to be rejected. So, there are altogether 4 different options. So, then let us see what is this particular structure altogether. So, now in this case the structure is like this. This is actually the comment about the null hypothesis, and here the decision about the null hypothesis. So, null hypothesis is true and null hypothesis is false, and H 0 it will be rejected against null true and null false, and it will be failed to reject in the case of true null hypothesis and false null hypothesis. So, that means, here in the first case H 0 is true. So, now the structure is here failed to reject the null. So, that means, you are not in a position to reject the null hypothesis when it is true. So, as a result it is actually declared as correct decision. So, now in the counterpart you are rejecting the true null hypothesis. So, that is what it is called as type 1 error. So, now type 1 error, which is nothing but called as alpha, and that is specified in the kind of normal distributions as alpha specification, that is the point through which you have to check the significance level. So, now in the type 1 errors, the interpretation will be it is the rejecting the true null hypothesis, and then means the degree through which you are rejecting the true null hypothesis is nothing but called as alpha. And then in the case of false null hypothesis, that is actually a type 2 error, that is the concept called as beta. So, now that is actually, so the false null hypothesis to be accepted. So, that is what actually called as type 2 error, otherwise it will be the correct decision. So, that means technically it is the game between this particular diagonal. So, here alpha is one particular component and beta is another particular component. Alpha 1 is called as a type 1 error. So, here the interpretation will be it is the probability through which you are rejecting the true null hypothesis, and in this case it is the probability through which you are accepting the false null hypothesis, and at a particular point of time your alpha plus beta exactly equal to 1. Since total probability equal to 1, so your alpha and beta will be represented as a equal to 1s. So, now corresponding to this particular structures, you have to go for empirical testings. Now, see here in the red zones we first specify the alpha null hypothesis structure, and then specify the type 1 error, that is the alpha percentage. So, alpha will vary from actually 0 to 100. So, you have to specify whether it is 1%, 5%, 10% and like this. Then accordingly you have to find out critical value depending upon the test statistics and the kind of degree of freedom. So, now so in this case this is the typical structure, this is the typical structure called as one tail test in the left hand side, and this is the structure is called as right hand side. So, now corresponding to this actually your null hypothesis and alternative hypothesis will be like this, and this is, if this is the null and alternative hypothesis, then you are targeting this side of testing. So, when your null hypothesis is like that, that means mu less than equal to 40 and mu greater than 40, then your testing zone will be this side. So, that means we like to see actually whether your test statistic will be in the rejected zones, or if you are testing this side, then you like to check whether null hypothesis will be this side or it will be in the accepted zone. So, this is the structure called as one tail structures. If not, then we will move to a structure called as two tail test. Okay. So, in that case both the sides has to be taken into considerations. So, now in this case if you are putting alpha equal to 5%, then 50% will come this side and 50% will come to this side. So, as a result your target of testing will be this sides and this sides, and this is what actually called as accepted zones. So, now again on the basis of fixing null hypothesis and alternative hypothesis and the alpha fixations, you have to find out the critical value and specify the rejected zone and specify the accepted zones, and then you have to see where is the position of your sample test statistics. So, the position of the sample test statistic will give you the kind of inference, and that to comment on the null hypothesis and alternative hypothesis, that means whether to accept the null hypothesis or to reject the null hypothesis. So, accordingly, so we have to go for the kind of structure, then we will take a decision as per the particular problem requirement, right. So, let us move to this particular structure, and here I will give you a simple examples corresponding to this problem. So, now I will give you a simple examples. Let us say in the previous case we are fixing mu equal to 40, but here we are fixing mu equal to 74,914, and then the counterpart will be not equal to 74,914. So, this is actually some kind of examples. That means, let us assume that it is the average income of a particular location, and then we have to take these samples and then check whether the sample statistic will be converged to this population statistic or not. And for that, the typical structure we have to follow like this, and we have actually standard test statistic structure. So, that means we have a Z test, T test, chi-square and F, and more or less every test structure will follow like this testing procedures. So, what will you do actually in here? So, we have to take one examples, and then with the help of test statistic, we have to see the structure of testing and the kind of inference which we will get, and accordingly we will take some kind of management decisions. So, now in this case, so your so we are putting alpha equal to 5%, that is the type 1 error, and that is what actually in the testing procedure we call as probability level of significance. And since we are targeting here both the sides, that means it is a two-tailed representation. So, by default 0.025 will become this side and 0.025 will be coming in the right side. So, that means it is nothing but alpha by 2 and alpha by 2. Since alpha is 5%, so 0.025 is the left side and 0.025 will be the right side, that is the rejected zones, right, and the rest of the area, that is the 95% area, will be the accepted zone. So, that means technically, so again this is the 95% area which is called as accepted zones, that is non rejection zones otherwise, and out of which this is actually a rejected zones 50% and rejected zones remaining 50%, that means 0.025 and 0.025. Now, corresponding to this alpha, and if you choose a particular test statistics, let us say Z. So, that is normal distribution, standard normal distributions. So, now corresponding to actually alpha means this value 0.025, then your Z value will be represented as minus 1.96, and accordingly this side will be 1.96. So, now I will tell this is actually derive, this critical value typically derive on the basis of Z tables only. So, in the next slides I will show you how exactly exactly coming this particular value. So, see here. So, this is what actually the standard normal tables. So, we are targeting actually 95% and that to 1.96. So, that means, so here the target is 1.96 means, so this is actually 1.9 and 6 means you will come to this side here. So, that means technically this person 0.975, and that 0.975 means, so if you go to the previous slides, then you can get to know the particular structures. Okay. Okay, so here minus 1.96 and here 1.96, that means 0.025. So, corresponding to that particular value, so it is actually specified 0.975. So, as a result your Z value will be 1.96, and that is what the critical value all about. And then on the basis of critical value, so so this is what clearly specification how the Z critical value will be reported, and then accordingly, so you can actually go for some kind of testings, right. So, so this is what actually the particular structure, and in the case of two-tailed test fixing alpha value, then alpha followed by alpha by 2. So, the decision rule will be like this, your null hypothesis will be rejected when your Z calculated will be greater than to Z criticals, right. So, that means technically, so the decision will be reject true null hypothesis when your test statistic Z test statistics calculated test statistic will overtake the Z critical 1.96, and if not, then you have to you cannot reject null hypothesis, that means you have to accept the alternative hypothesis, and in that case your Z calculated will be less than to Z critical, that is 1.96, right. And the corresponding to this particular structure, so the decision rule will be like this. So, in a particular examples which you have already highlighted. So, your let us say sample this is actually sample statistic structure, and this is mu and standard deviation are population parameter, and this is the Z test formula, and we have already discussed in the last lecture. So, now knowing having the information about population mean mu and population standard deviation sigma. So, then you just report the sample statistics, that is x bar, and then you have to simplify, you will get the value called as z equal to 275. Now, on the basis of alpha fixation 0.5, that too again for 2 tell 0.025, and then we are getting z critical is 1.96, and since z equal to 1.96 and here the value is coming, test statistic value is coming 2.75. So, as a result 2.75 is greater than to 1.96. So, that means it is definitely it is in coming under the rejected zones. So, we are in a position now to reject the true null hypothesis. So, your decision corresponding to this problem and information you have to reject the true null hypothesis. That means, the statement which you are putting, so that is actually correctly specified. So, the decision will be like this, and then okay. All right. So, the structure is followed like this. So, in the previous lectures we have discussed actually these are all actually sample statistics, and then with respect to sample value the following structure can be converted into Z structures, and when population mean equal to 74,914. So, that means, if you go by Z transformation, so in that case Z will be exactly equal to 0. Okay. So, this is the actually the kind of mean, and that is how it looks like symmetrical distribution, and then the confidence interval will be minus 1.96 to 1.96, and now on the basis of Z value. So, the Z calculated. So, it is appearing that it is going in the rejected zone. So, as a result, so you are rejecting the true null hypothesis. But on the basis of this particular structures, we will find here one particular inference, that is the kind of confidence interval, that is the lower limit and upper limit. Since we have already specified the critical levels in the left side and right side, and corresponding to these critical value. So, the kind of structures you have to find out the lower limit zone and upper limit zones, and the lower limit zone will be. So, that is nothing but actually specification about the kind of sample means. So, sometimes it may not be directly converts to population mean. So, as a result, so what we will do, we will find actually kind of interval. So, the interval will be mu plus minus Z statistics followed by Z critical and then sigma by root n. So, as a result, so corresponding to this particular value, so here the lower limit structure will be like this. So, mu is already specified, that is 74,914 minus Z critical, which we have already calculated 1.96, and sigma is already specified there, and on the basis of sigma and n is here assuming that 112, and then accordingly. So, the lower limit figure will be coming actually 72,223, and corresponding to the lower limit, the upper limit will be mu plus Z critical sigma by root n. So, as a result, so this is actually the means, and then this is the Z criticals and corresponding the standard deviation by root n's, and then it will be coming 77,605. So, the mean is 74,914, and then the confidence interval will be created actually up to left side 72,223, that is the lower limit, and the right side it will be coming 77,605. So, that means, so the confidence interval for this mean mu equal to 74,914 is nothing but 72,223 and 77,605. So, that means, in a particular point of times you are in a position to report the significance of this particular structure to whether to accept the null hypothesis and alternative hypothesis, and corresponding to the population mean, we can actually report the kind of confidence interval. So, that means, the mean which you have so what should be the actually lower limit range and what should be the upper limit range. Sometimes it is very difficult to find a situation that your sample statistic will be exactly converse to population statistics. If not, then we have to create a confidence interval, and that confidence interval will give you some kind of inference as per the kind of problems, and then accordingly you will take some kind of management decision. So, now corresponding to this particular structure, so I will give you another example here, and see here. So, now here x bar is the lower limit, x bars 77,223, where x greater than 77,605. So, that means, so the lower limit range is 77,223. So, now if the test statistic actually having less than that, then that will be actually rejected, and then in this case upper limit is 77,605. So, if the test statistic coming greater than to that, then it will be coming under the rejected zones. So, now in this particular case, since x bar is coming 78,695 and which is greater than to 77,605, then by default you are actually now rejecting the true null hypothesis. So, that means, actually the whole idea is that on the basis of your population parameters and the sample statistic, you have to find out confidence interval, typically in the case of two-tailed test. So, now the confidence interval will be actually lower limit, it will give you the idea about the lower limit and upper limit. So, now if your test statistic is falling falling lesser to the lower limit and then higher to this upper limit, then you are actually in a position to reject the true null hypothesis, and that is the decision which you have actually taken into considerations here, and that to as per your problem requirement. So, now corresponding to this, so another examples which I can cite here. So, now let us say mu equal to 4.30 and then the counterpart will be mu less than to 4.30. So, now again we will go by one tail test here, because the alternative hypothesis fixed at actually mu less than 4.30. So, as a result if you are putting actually alpha equal to 0.05, alpha equal to 0.05. So, then the z critical will be minus 1.645. So, that means, again you go to this probability structure, and then corresponding to that 0.05. So, you will find z critical will be minus 1.645. Then again you will calculate the test statistics, and then you will see the position of test statistic, whether it is coming under the rejected zones or it is coming under the accepted zones. So, now once you will actually in a position to calculate, then you will take a decision accordingly. So, here okay, so this is what the particular structure. Now, so the z critical will be minus 1.645, and in this case, on the basis of informations, your x bar is coming, that is called as sample statistics. So, it is coming 4.156, and the population statistic is given, that is 4.3, and that is nothing but actually mu specifications, and S is here given 0.574 and n is given 32. So, as a result your z calculated will be minus 1.42, and if you compare here, this minus 1.42 is actually, this is actually critical zones minus 1.645, and then your minus 1.42 is actually coming on this sides, minus 1.42 means it is coming under this side. So, as a result, so you are not in a position to reject the hypothesis. So, that means, so in this case we have to accept the alternative hypothesis. So, that means it is very much clear that so on the basis of your population information, or the specification of population parameter. So, you have to calculate the sample statistic and then check whether the sample statistic is coming within the confidence interval or going beyond the confidence interval. That means, whether it is actually coming a lower to lesser to the lower bound and higher to the upper bound, then you are in a position to reject the true null hypothesis. If not, then it will be coming in a kind of confidence interval, that is what is called as a accepted zones, and if your test statistic value will be lying on that particular zones, then you are not in a position to reject the true null hypothesis. In that case, you have to accept the alternative hypothesis. So, now the decision is very much clear here. So, the typical structure is that you are going to investigating a problems. So, in the once you go through this problem, so you have to specify the particular comment what we need to actually test, and the comment which need to specify corresponding to that problems is nothing but the formulation of null hypothesis. And then, so your observation is or your testing structure or inferential structure is, so whether to accept this particular statement or whether to reject the particular statement, then in that case you have to collect the information, choose the test statistic, choose the kind of probability level of significance, then there is a kind of structure through which you have to take a decision. So, the structure is like that your the sample test statistic should be compared with test statistic critical value depending upon the sample size and the fixation of alpha, that is the type 1 error, and then if your test statistic value is coming under the accepted zone, then you are not in a position to reject the true null hypothesis, and if not, then it will be coming under the rejected zone. So, in that case you have to reject the true null hypothesis. Then accordingly, depending upon your fixation of null hypothesis, you have to take a decisions, and then the inference will give you some kind of management decisions as per your problem requirement. With this we will stop here and we will continue from from this in the next lectures. Thank you very much. Have a nice day.